is my son asking me to spell for him. Okay, here we go. What are ionic compounds made of?
Metal and non-metal?
Perfect. A metal and a non-metal. Goes a long way back. And what's happening in an ionic bond with your electrons?
Transferring electrons.
Good. So there's transferring. So there's a positive and a negative. That's what makes ions. And those positive and negative ions track together to create an ionic bond. When you're naming them, name the metal first and then the non-metal, change the ending to IDE. That is on your nomenclature flowchart. So if you're stuck with that, or if you don't remember exactly how that works, grab your nomenclature flowchart. It's not hydrogen, it's not two nonmetals. Okay, it's a metal and a non-metal. So here's your naming. Name the metal first, see if the metal has more than one charge. Name the non-metal second, change the ending to IDE. Okay, so use your nomenclature flowchart for the naming here. So what would CaO be? What would the name of CaO be?
Calcium oxide.
Good. Calcium, Ca is calcium. O is oxygen. We change it to oxide. And we have to see, do the transition, is calcium a transition metal with more than one charge? Do I need to include charge in brackets after calcium?
No.
No, calcium is only never a +2 charge, so I don't have to put brackets there. How about potassium? Sorry, K3P. What is that compound?
Potassium phosphide.
Good. And Kira, does potassium need brackets? It doesn't have more than one charge.
I don't think so.
Good. It does not. It's only never +1. How about CuS? What's this one?
Copper 2 sulfide.
Oh, and we have a 2 in here. How do we know it was 2? How did we know to put the +2 there?
Because there's more than one charge.
Good. And how did we know it was the +2 and not the +1? Melody.
Because sulfur also has a 2- charge, so they canceled. So it would have been both 2s, so they can cancel.
Awesome. So sulfur on the periodic table. So this is why you guys will need this handy, because I'm sure we don't have all of this memorized. Sulfur on the periodic table has a -2 charge, and it's just a 1-to-1 ratio in CuS. So that has to be the copper +2 to cancel out the -2. So pay attention to the charges on the non-metal. That will help you figure out the charge on the metal. If it's a transition metal, if it is a metal with more than one charge, because you have to remember to include the charge in brackets if it's a transition metal. Questions on ionic compounds nomenclature with writing the names when you're given the formula. All right, now we're moving to the opposite. Write the formulas. So if it's an ionic compound, you write down the symbol and the charge for the metal and non-metal, do the swap and drop. Remember to reduce if necessary. So again, that's on the back of your periodic table here. I go back to my ionic section, write down the symbol and charge of the metal and non-metal, swap and drop, reduce if possible. Okay, so my first one is magnesium chloride. What's the symbol and charge for magnesium?
MgCl2.
Okay, so first I'm just going to write down the symbol and charges. Magnesium is +2, chlorine is -1. You do the swap and drop. So drop just the numbers, not the positive and the negative symbol. And then we do get Mg. We don't need to write the 1. Cl2. Can that be reduced? No, it can't. So that is magnesium chloride. How about lithium nitride? What am I going to do for this one?
LiNO3.
Okay, this is nitride, not nitrate. So it's got to be really careful with the ending here. This is actually just nitrogen. So nitrogen is just N-3. So what will that be? We swap and drop.
Li3N.
Good, just Li3N. And it cannot be reduced, so that's it. All right, the last one down here for ionic is nickel to bromide. What's the brackets telling me about the nickel?
Nickel has a charge of 2.
Good, this is the +2 ion. So nickel must be a transition metal with more than one charge. And what's bromine's charge?
-1.
Okay, good. So Stephanie, what is the formula for nickel to bromide?
NiPr2.
Very good. Any questions with writing formulas for ionic compounds? Okay, now we're going to move on to polyatomic, which is very similar to ionic, but what are polyatomic compounds made up of?
Metals and polyatomic groups.
Good. Give me a so. It is going to start with a metal, just like a ionic compound, but with polyatomic, instead of just being a metal and one nonmetal, it's a metal with a nonmetal group. And those are all listed on your periodic table for you guys with the formulas and the symbols here on the bottom right. So if it's a metal plus a polyatomic ion group, you're going to look at this chart over here. So keep that handy. What would be the name of CaCO3?
Calcium carbonate.
Thank you, Stephanie. So calcium, and then the CO3 is a polyatomic ion group, so that is calcium carbonate. How about KPO4? So I have 3 capital letters indicating there's multiple atoms here in this compound. What's its name?
Potassium phosphate.
Awesome, Kira. Potassium phosphate. And how about CuSO4?
Copper sulfate.
Okay, close. Sophia, what do we need to include here with copper sulfate?
Oh, the 2.
Good. Good, because with transition metals, remember you have to include charge in brackets. Okay, so ionic and polyatomic compounds, very similar here with how you write the formulas and also how you name them. So writing formulas, again, write the symbol in charge, swap and drop, reduce if possible. But remember with polyatomic compounds, you need to remember to put brackets if you drop a number behind the polyatomic compound. Otherwise, it's going to look really confusing as to what you're writing. So magnesium chlorate, what's the symbol in charge for magnesium? It's Mg+2. How about chlorate?
ClO3 with the charge of -1.
Good. So Stephanie, when you swap and drop, what do you get from magnesium chlorate?
Mg bracket ClO3 close bracket 2.
Very good. And thank you for including the brackets. So we put the brackets around the ClO3 to show there's 2 chlorate groups. Otherwise, it's going to look like MgClO32. So include brackets around the polyatomic ion to make it clear as to what that compound is. Okay. How about lithium nitrate? Symbol and charges for lithium and nitrate.
Lithium is +1 and nitrate is NO3 -1.
Good, Sophia. So what's lithium nitrate's formula?
LiNO3.
Awesome. Oops. Gotta make sure that's capital O, LiNO3. Because the 1 and the 1 cancel, I don't need any subscripts there except for what's already in my polyatomic ion group. NO3 is nitrate. Questions on polyatomic ions or compounds? Okay, let's move to molecular. What's the difference? What are molecular compounds made up of?
Non-metal plus a non-metal.
Awesome. Thank you. Yeah, so it's going to be a non-metal and a non-metal. So with molecular compounds, they are sharing electrons. It's a covalent bond. We don't have ion charges being formed. So we don't look at the charges. There's no transfer of electrons. There's no positives and negatives here. They're sharing. So with molecular compounds, you use prefixes to show the number of atoms that are in the compound. Again, using this flowchart, non-metal plus non-metal. When you're naming them, write down the name of each non-metal, add the appropriate prefix in front. So mono, di, tri here in this chart. Do not reduce. Okay, so looking at the top right, that purple section for molecular compounds. So what would be P2S3? First of all, these are both non-metals if you look on your periodic table. You do have to be able to identify this. If you look at your periodic table, P and S are both over here in my coral colored section in the non-metal group. Okay, so be able to find them and identify this is molecular. What's the name for P2S3?
Is it diphosphorus trisulfide?
Good, diphosphorus trisulfide. And I did have somebody message me, you can spell sulfide or sulfate with PH or F. Both are considered acceptable, so don't worry about that. It's going to be multiple choice, so you're going to find it anyways. How about PCl3?
Phosphorus trichloride.
Awesome, Kara. Phosphorus trichloride. And how about CCl4?
Carbon tetrachloride.
Good, Stephanie. Again, these are all on the right side of my periodic table. Okay, so they're all nonmetals bonded with nonmetals. Writing the formula, use the prefix to determine the subscripts. We like this kind because we don't really have to worry about charges or any of that other stuff. Okay, what is selenium dichloride? What would be the formula for that?
SeCl.
There's a prefix there too, Sophia.
Oh, SeCl2.
Good. Sorry guys, my pen just completely stopped working. Let me see if this works. Oh, good. SeCl2, because that di right there. Good. How about dinitrogen trioxide?
N2O3.
Good. And how about arsenic tribromide?
AsBr3.
Good. So sometimes you might have to look at the symbols to make sure you know what the symbols are. But the tri here is telling me there's 3. So this is nice and easy with the prefix. Make sure you include the proper subscript. Questions on molecular compounds? All right, then we got into balancing equations and then types of equations. Why do we have to balance chemical equations?
Is it because of the law of conservation of mass? It's like you can't create something from nothing, like you can't create more than what there was originally.
Exactly. We have to show the law of conservation of mass, which is a law, is true here. So the number of atoms on the reactant side have to equal the number of atoms on the product side. We can't create or destroy matter. So those atoms on both sides have to be equal. So it's demonstrating the law of conservation of mass. Does anybody want to balance this first one here for us? I have sulfuric acid plus magnesium makes magnesium sulfate and hydrogen gas.
Is it already balanced?
It is balanced. Good, Kira. So I have 2 hydrogen and 2 hydrogen, SO4 and SO4, magnesium, magnesium. That one's balanced. How about number 2 or B? I have sodium chlorate makes sodium chloride and oxygen gas.
Oh, one in front of the O2?
A 1?
Yes.
Okay, so I'm actually not gonna put a 1 from the O2. So remember, I have an odd and an even with my oxygens. So what do I do if I have an odd and an even situation?
You put a 2 in front of ClO3.
Yeah.
A 2 in front of NaCl, and then a 3 in front of O2.
Okay, good. So I'm gonna put a 2 here to make double the odd number. That's gonna be 6 oxygens. So Kira said to put a 3 here to get my 6 oxygens. Now I have 2 sodium and 2 chlorine, so I need to put a 2 here as well. And that's balanced. So one of our tips was if you have an odd and an even situation, double the odd, make that an even number, and then work out the rest of the elements that are present. Okay, any questions on B? How about C? I have arsenic trichloride plus hydrosulfuric acid makes hydrochloric acid and arsenic trisulfide. What do I have to balance here?
Would you put a 2 in front of ASCl3 and then a 3 in front of H2S and then a 6 and then 1?
Okay, so Nathaniel, I think I said heard you say this. So let's just check that out. 2 arsenic, 6 chlorine, 6 chlorine, 6 hydrogen, 6 hydrogen, 3 sulfur, 3 sulfur. Nice, Nathaniel. Questions on C? So remember, it's a lot of back and forth, try to get to balance out. If it doesn't work, or try starting in a different spot. And just keep doing your left-hand, right-hand check. Then we got to types of reactions. What is a synthesis reaction?
A plus B equals AB.
Good. And what's happening here, Mia, with my reactants?
It's a type of reaction that has 2 or more reactants that join together to form a single product.
Awesome. You have 2 or more reactants. They're all bonding together to make one more complex reactant. How about decomposition?
AB equals A plus B.
Good, Nora. And what's happening here, Nora, with this equation?
It's where the compound turns into 2 single reactants.
Good. So you start with a complex reactant, usually multiple atoms in my complex reactant, breaking down into simpler products. Good. How about single displacement?
AB plus C becomes A plus BC.
Okay, so what you said is fine, Stephanie. I'm just writing it a little bit different, so it's closer to what we did in class, but that's fine. And what's happening here, Stephanie?
One of the things is being displaced, but it's a
Good.
different one than the first one.
Good. So you have a single reactant and a compound as a reactant. The single reactant, if it's strong enough, will kick out one of the parts of the compound and steal its partner. So you end up with a new element and a new compound as your product. How do we know what's going to happen in a single displacement reaction? What do we look at? Melody,
The metal activity series, I think, and
good.
whichever element is higher, that's the one that can actually displace.
Awesome. So you need to reference your activity series. If the higher metal is the one that's by itself, it's strong enough to break this bond in the compound. If it's a lower metal, nothing will happen. It's not strong enough. It will still remain by itself and no reaction will actually happen. So you will probably want to have pretty handy your activity series next week. All right, how about double displacement? What's happening here?
AB plus CD equals AD plus CD.
Good. And what's happening here, Sophia?
I'm pretty sure two are displacing another two.
Yeah, you start with two compounds, and in the end, you have two brand new compounds because two elements have switched places and switched partners. Awesome. How about complete combustion? What's happening in complete combustion?
CXHX plus O2 equals H2O plus CO2.
Good. So you have a hydrocarbon burning in oxygen. It's going to make carbon dioxide, water, and release a lot of energy. We had a bonfire here at our family had one on Saturday, and just combustion reactions just to me are just so fascinating to watch that. Fire and energy, just really, it's an amazing thing. But you have a hydrocarbon, you need oxygen, otherwise the fire won't burn, the combustion reaction will happen, produces carbon dioxide and water, this is water vapor, and releases light and heat energy, sometimes sound as well. All right, so let's use what we just talked about to figure out what is going to happen in these reactions. First of all, what does the first one look like? Is it synthesis, decomposition, single, double, or combustion?
Single displacement?
Good. Sodium is by itself, and I have a compound. So this looks like it's going to be single displacement. Does anybody have their activity series handy to know, is sodium stronger than magnesium? Sodium is,
Sodium is
yes.
higher.
Thank you, Melody. Sodium is higher on the list. So sodium can steal magnesium's partner. So Melody, what are the products going to be here?
Would it be magnesium? Actually, I'm not sure for this one.
Okay, good. So magnesium will get kicked out by itself. Sodium is going to bond with sulfur. So what's the formula for sodium bonding with sulfur? Sodium is +1, sulfur is -2. So what's the formula going to be?
Na2S.
Good. This question then says balance it. I won't have a multi-layered question like this on your exam, but you could then balance these out. I have 2 sodiums over here, so I need a 2 here. And actually I think that's it. 1 magnesium, 1 sulfur, 1 sulfur. Yeah, that's it. This one I'm actually going to skip because we're going to stick with just the single displacement with metals, not non-metals. So don't worry about that one. But look at Al plus Br2. What kind of a reaction does that look like is going to be?
Synthesis?
This looks like synthesis. Sodium and bromine are both elemental forms, so they're very simple reactants. They're going to bond together. So please pay attention to your periodic table. Don't just put AlBr2. You have to remember your charges. and do swap and drop. Aluminum is +3 and bromine is -2. So what's aluminum bromide's formula going to be?
Al2BR3.
Very good. Please always, always, always check your periodic table, check charges. You can't just grab the subscripts from the reactant side because those subscripts are from whatever balanced equation made that compound, and you're making a new compound in the reaction. So always have to do swap and drop. Does anyone want to balance this one out?
Put a 3 in front of AL.
Put a 3, so I have 2 on the right, but I actually have an odd and even situation, Stephanie. Let's start with bromine. How do I fix this problem?
Put a 2 or a 3 in front of bromine and then
And a
a
2, yeah,
Yeah.
and now how many aluminums are here on the right?
4. So put a 4 in
Good.
front of AL.
Awesome, awesome, awesome. Okay, good. So if you have odd, even, start there and then work through the rest of your elements. How about the next one down, PbNO3. So that's lead to nitrate plus aluminum iodide. What kind of a reaction does this look like it's going to be?
Double displacement.
Double displacement.
Good. Double displacement. Okay, what's going to happen here then? Somebody just tell me the names of the compounds that are going to form. What will lead bond with? What's the lead going to bond with from this one? So this is A, B plus C, D. A is going to go with D. So what's D?
Iodine.
Good. So I'm just going to write down, we said it was lead to iodine is -1. I'm just going to write them there for now. And C is going to go with B. So what's my second compound? Aluminum is going to bond with nitrate. So I'm remembering swap and drop. If it's lead 2 with iodine, this is going to be PbI2, doing swap and drop. PbI2 plus AlNO3. Questions on this one? Okay, anyone want to balance this one? Got a couple odds and evens. I have 3 nitrates on the right, so I'm going to double that one and put a 3 here. That gives me 3 lead. So I'm going to try a 3 here and see what happens. That gives me 6 I's. So I need a 2 here. I think I'm balanced now. 3 lead, 6 nitrate, 6 nitrate, 2 aluminum, 6 iodine, 6 iodine. Questions on that one? That was probably a more complex one with all the swap and drop and the balancing. Questions? All right, how about the last one? What kind of a reaction is this going to be?
Single displacement.
Thank you, Mia, for guessing that, because that's often our reaction because we see oxygen by itself, but this actually is not single displacement. Melody, what do you think? It is complete combustion. Yeah, no, it's fine. This is complete combustion. This is my hydrocarbon and oxygen. So what's formed in complete combustion?
Carbon dioxide and water.
Yeah. You guys can put plus energy if you want, but I don't have to balance energy, so that's okay. And let's see if we can balance this. So I have 4 H's, so I'm gonna try a 2 here. That gives me 2 plus 2. Oh, so try a 2 there. I think we're balanced. C4, yeah, 4, good, okay. Questions on predicting products, balancing, reaction types is kind of a little bit of everything here. Questions? Okay. I wanted to also just include acids because that seemed to be one that we got a little bit stuck on in the unit. So remember, acids are on the back of the periodic table. So they're going to be over here on the left. If you have hydrogen with a halogen, follow the far left. If it's hydrogen with a polyatomic ion group, follow this other path here. Okay, the difference is if it's just hydrogen with a halogen, you start with hydrochloric acid, hydrofluoric acid. You start with the word hydro. If it's a polyatomic ion group, you don't. It's just nitric acid or sulfuric acid. So that's kind of the big difference here with the acids. So remember, that's on the back of your periodic table. So looking at this, H2CO3. This is hydrogen with a polyatomic ion group. So what is this name?
Carbonic acid.
Oh, thank you, Stephanie. Carbonic acid. So CO3 is carbonate. So it's closest to carbonic acid. And I don't use the word hydro in front because it's not just a halogen. How about HClO3? What's this one? It's chloric acid. ClO3 is chlorate. So that's chloric acid. How about HF?
Is it fluoric acid?
Lila, you're really close, but look at the far left column of the top left on the back of your periodic table. Because it's just a halogen, you do need to start with hydrochloric acid.
Oh, hydrofluoric
Yeah,
acid? Okay.
yeah. Let me just put up here. Acids consist of hydrogen plus metal or halogen, I should put it. Or polyatomic ion. Okay. So let's do some formulas. These are very much like your polyatomic ions. So you're going to do swap and drop. However, they all start with hydrogen. So that's going to be the tricky part. Nitric acid is nitrate plus hydrogen. So the word hydrogen is kind of hidden if it's with a polyatomic ion group. So if you see the word acid, look at the back of your periodic table. Use this flow chart. So acids, here, write down the symbol in charge of the hydrogen and the polyatomic group. Swap and drop, reduce if necessary or if possible. So nitric acid, I'll do this one for you guys, is hydrogen plus nitrate. Hydrogen being +1 always, when it's with a polyatomic ion group, and nitrate is -1. So this is just HNO3 with the swap and drop. How about sulfuric acid? Doesn't start with hydro, so it's with a polyatomic ion. Which group is it with?
Sulfate.
Good, so SO4 -2. So swap and drop, that becomes H2SO4. And how about hydrochloric acid? Starts with the word hydro, so what's happening here?
Hydrogen and chlorine.
Good, and chlorine is a -1, so it's just HCl. That's going to be probably one of the harder components to remember what we were doing there. So please have the periodic table handy and use the back very closely. And hopefully that's going to be a big help to you. Okay, what we're going to do as a review next is you guys are going to log into Socrative. I'm gonna do a space race of just chemistry. So I just needed to see how many teams I had to make first before I started this. So go to Socrative student login. What are we gonna be today? Let's be a B. All right. Socrative student login. And at the top of my page, you guys can see our class name is Read Science Class. And then if you guys could just put in the chat what color team you are on once you've logged into Socrative.